Hello everyone. In this section, we will discuss about graph and loss visualization using TensorBoard. So basically, we have already discussed about the TensorBoard, and the basic idea behind TensorBoard is that neural network can be something known as a black box, and we need a tool to inspect what's inside this box. So you can imagine TensorBoard as a flashlight to start dive into the neural networks. So it also understands the dependencies between operations, how the weight are computed, and how we can display the loss function. So let's discuss about the graph. So basically behind of this graph is that a neural network decides how to connect the different neurons and how many layers before the model can predict an outcome. Once you have defined the architecture, you not need to train the model but also a matrices to generate the accuracy of the prediction. So this metric is referred as a loss function, and this objective is to minimize the loss function in different words. So to minimize the loss function, you need to define a learning rate. So as you can see that in this figure, the scalars tab shows changes in the loss and the matrices over the epoch. So it can be used to track other scalar values such as learning rate and training speed. Now we will discuss the implementation of this. So in this example, first you must install the latest version of TensorFlow. Now to able to use the TensorBoard, we must load the first TensorBoard extension by using this command. After that, I have imported the TensorFlow library along with the datetime library. Now I will load the dataset, and for this I am going to use the Eminest dataset under the tf.keras.datasets.minist, and then I load the train and test data as xtrain, ytrain, xtest, ytest. Since the input features are between 0 to 255, I will just normalize it by dividing 255. I have created a new sequential model with a single dropout layer as model equals to tf.keras.models.sequential. So in the first layer, I have created a flattened layer that will take the input images of shape 28, 28. In the second layer, I have created a dense layer with 512 neurons and the activation function as ReLU. And it is dropped out by the layer with a dropout rate that is 0.2. And the final output layer has created a dense layer with 10 neurons with the softmax activation function. Now we will display the summary by using model.summary. So as you can see that the output shape has been come 784, 512 which has been neurons, and 10 is the output neurons. So before I can call the fit on our data, I will just specify the path and the folder name in which it should be saved. So this will place the logs in a timestamp subdirectory which we can use to access later. And now I will configure the TensorBoard as tf.keras.callbacks.tensorboard, and the histogram value that I have mentioned is 1, which means I want a histogram computation for every epoch. Now to access that in the support interface, we must use the command. So after that, I have used the model.fit in which I have mentioned the xtrain and ytrain and epoch value that is 20. Now to access that in the support interface, we must use the command TensorBoard --log directory and the directory name. And we have now the TensorBoard. As you can see the graph, we have separate graphs for accuracy and the loss in our case. So both training and validation accuracy are increasing simultaneously. So with this we have completed graph and loss visualization using TensorBoard.